one of the primary functions of a chemist is in the observing, attempting to understand, manipulating, or altering the properties of matter. So if this is so important, just what are the properties of matter? Well, the properties of matter are the characteristics of the substance under observation. These properties or characteristics can either be directly observable, for instance, looking at the color of a car, or it could be the manner in which something interacts with other substances in the universe. For instance, if you were to pour vinegar onto baking soda and observe the bubbling that occurs there. When we look at the properties of matter, we can categorize them in one of two ways. They're either physical in nature, or they can be chemical in nature. Oftentimes it's difficult to tell the difference between the two, so we're going to have to be careful, and this is one of the things that we're going to have to spend a little bit of time thinking about. Physical properties are the characteristics of matter that can be observed or changed without altering the substance's composition or identity. So for instance, if you looked at an apple and you said, oh, well, that apple is green, all right, that would be a physical property of the apple. If you took a piece of paper and you were to tear that piece of paper, the fact that it can tear is a physical property, because although you have changed the paper, you changed the way that it looked, you still inherently have paper present there. You haven't changed it to something different, so the identity has remained the same. Chemical properties, on the other hand, are the characteristics that determine how the composition of matter changes as a result of contact with other matter or with the influence of energy. So for instance, if we take vinegar and we add that to baking soda, we see that there's a bubbling that's happening there, and we're going to create some new substances in that. So that's a property of both the baking soda and the vinegar, that when they are combined or come in contact, that they will react that way. If we added a lot of energy to that paper, eventually we would get to the point where it would gain so much energy that it would start to burn. And so that would be a chemical property of the paper. As I mentioned, it's going to be important for us to be able to differentiate between both physical properties and chemical properties. So let's take a look at a few examples here. And again, what you're trying to look at here is that property inherent to the particular substance, or does it involve how that substance interacts with another substance or with energy? And again, sometimes these can be a little tricky. So the first one that's listed here is the boiling point of ethyl alcohol is 78 degrees Celsius. Second one is diamond is very hard. And finally, sugar ferments to form ethyl alcohol. So if you want to pause the video and take a couple minutes to think about these, it would be worthwhile to do that, and then go ahead and push play again to get the answers. So for the first one, this is a physical property. Boiling point is an inherent characteristic of the substance. So you're not going to, although you are adding energy to it, which would make you think that it could potentially be chemical, you aren't changing the substance at all. Diamond being very hard, that's a more standard kind of physical property. And the fact that sugar ferments, that indicates you have a new substance forming there. That's going to be a chemical property or a chemical behavior of the sugar. And so again, kind of recap. Chemists are always looking at the properties of substances, trying to understand those properties so that they can modify or alter them, to make things that are going to make our lives better.